In this first look at jump, we're going to open a native jump data table, have a look at the main features of jump, and then start summarizing some of the variables within the data file. Now you can see in this directory I've already downloaded the Big City Zoo jump dataset. The little jump icon there says it's in the native jump format, as is indicated as well under the type jump data table. So all that we have to do in order to open this file is double click on it. Now this is the first time I've used this installation of jump, and because of that there are going to be one or two messages that potentially come up that won't always come up. So as you can see, the data file has opened. It looks at first glance something like an Excel spreadsheet. It's certainly got rows, which are cases, and columns, which will be variables, but you don't really do anything with the cells in this table. They're just numbers. All of the action in jump comes from the menus going across the top: file, edit, tables, rows. And in fact, from the analysis point of view, what we are going to focus on is the functionality that's available under the Analyze menu. So we'll have a look at that in just a minute. So anyway, here's the data table. Now there are some things that we can point out straight away that is provided to us from the description of the table itself, and in particular I'm looking at rows down here, and you can see that there are 944 rows in the table. Looking under the column summary, you can see that there are 19 columns in the table as well. Now, in this data set, the key variable of interest is this one: daily zoo attendance, number of people coming to the zoo each day. But there's a whole bunch of other things here as well. For example, the date that the observation was taken on, and so each row corresponds to a day here. And there are going to be other variables of interest as we go along. Total ad stock is the summary aggregate measure of all the advertising that's going on that particular day. And you can see other variables that might well have an association with attendance. For example, maximum temperature. It's a hot or cold day. Gas price is often thought to be important in terms of consumers making a decision that involves some form of transportation. And furthermore, we have a lot of weather related variables in this data set, and it would not be at all surprising, might well have an impact on whether or not somebody is coming to the zoo on a particular day. So let's have a look at our key variable of interest, which is daily zoo attendance. And in order to analyze a single column, you go to the Analyze menu, you click on the Analyze menu, and then you want to go to Distribution. Now once the distribution dialog pops up, you can click on whichever variable you want to have a look at. So we're going to look at daily zoo attendance, and you put it into the dialog as the Y variable. So I click on the Y, and now all that I have to do to have a look at this is click on OK. And when I do that, I get some jump summaries here. Now, as I said, this was the very first time that I've used this installation of jump, and it's quite likely that you will have the following dialog come up when you use it for the first time. Can you see under the top here there is a dark strip, and it's saying that there are menus available on this output, but they don't come up automatically. Now if you want to make them come up automatically, which is what I'm going to do, I'm going to go to the preferences in jump. So I do open preferences, and then Windows specific. There are lots of preferences we set, but the one that I'm doing is Windows specific because I'm working on a Windows machine, not a Mac. There are equivalent commands on the Mac. So Windows specific, and what I'm interested in is this auto hide menu and toolbars. At the moment the default is that it's based on the window size, and the jump logic is if the window is small it won't show you the toolbars, but I actually always want to see them whenever I have a window open. So I'm going to say click based on window size and say never. So if you never auto hide, then you always show. Now I'm going to click OK, and in terms of the output, if we have a look at it here, you can now see these menus sitting across the top, and those weren't there initially. Now again, that's a setup thing that I only have to do once. We can see in terms of the output that we've got a histogram, we've got a box plot, and we've got numerical summaries, and we will discuss those in more detail as we go on. In terms of laying this output out, some people would prefer a slightly different arrangement, and if you want to put things on a horizontal rather than a vertical arrangement, you can do that by clicking on the red triangle under distributions and saying stack. And if you create the output in that fashion, then as you can see, you have the histogram in the usual orientation, and here are what are called the quantars and the summary statistics. So this is looking at a single variable. Now, this particular variable that we're looking at, which is the daily zoo attendance, is what is known as a continuous variable. And you know that it's a continuous variable in JUMP because if you have a look at the table where it says daily zoo attendance, note that there's a blue triangle next to it. It's meant to be representing a histogram, and that icon says that this variable is being treated in JUMP as a continuous variable. And if I click on that blue icon, you can see it's telling me it's continuous. Now, I could, if I wanted to, change it to a different sort of variable, either ordinal or nominal. I'm not going to do that, but that's how one would change the variable type. Now let's have a look at another variable here that we might want to summarize, and let's have a look at the weather condition. So here's the weather condition variable, and I'm going to go through the same process where I do analyze distribution and then drop weather condition in as the y variable and click on OK. And now if you have a look at the output, you'll notice that it is different from when we summarized the attendance variable. And the reason is that attendance is a continuous variable, whereas the weather condition, as recorded here, is what is termed a categorical variable. So weather takes on distinct categories, and in terms of this data set, the weather has been defined in terms of 3 possible levels. We either have a rainy day, a snowy day, or a sunny/cloudy day. And so what these categories are really doing is separating out whether there's some form of precipitation against no precipitation. This is not a histogram, this is a bar chart, and what it's showing you is the relative frequencies of these categories occurring in the data set. So we can see that most days are sunny and cloudy, and because the bar on snow is so little, there's very few snow days, not surprisingly. Down here in the frequencies, you can actually see how many of the 944 rows fall in each of the categories, and under probability you're measuring the chances that a day from this data set drawn at random falls in one of these categories. If you just multiply the probability through by 100, you've just got the percentage of rows that fall within that category. So this variable is being treated differently through the distribution menu because it is not continuous, it is categorical. And we can see in the JUMP data table that it's categorical because it has the red bar chart next to it rather than the blue histogram. And so if I clicked on that, I could potentially change the type. It is being treated as what's termed a nominal variable, and that's what we're going to do through the course. But there is a different sort of categorical variable that is called ordinal, and that's when you have a categorical variable that has an inherent ordering in it. For example, low, medium, and high would be termed an ordinal categorical variable. So that's the first look at JUMP and how we summarize individual columns of data.